Hello, my math Jedi in training. Today we're going to talk about probability of compound events, and specifically we're going to do question number 6 from lesson 8 homework practice, probability of compound events. And the question says, one spinner can land on red, green, blue, or yellow, and another can land on right foot, right hand, or left hand. Each spinner is spun once. So let's get started. So we're doing number 6. If you'd like to make a tree diagram to answer the question, it would look like this. Since the first event had 4 choices, which were red, green, blue, and yellow, you'd start out with one set of branches representing the first event. From that, you would make another set of 4 branches because the second event also has 4 choices. Because things are getting a little tight, I'm going to abbreviate. So we had right foot, right hand, left hand. So I'm just going to do that throughout the tree. And since I did abbreviate, I'm going to make a key so that someone who's reading this can know what these abbreviations mean. So RF is right foot, and LF is left foot, and RH means right hand, and then LH is left hand. And that's a tree diagram. I could have also made a sample space, which I prepared ahead of time because it takes a while, just about as long as the tree diagram, but it's structured in the same way. This whole row is the reds, then the greens, then the blues, then the yellows, and looking at the tree diagram, you can kind of see that it really is the same thing, because that's the first set of branches: red, right foot, red, left foot, red, right hand, red, left hand, and that's showing up right here in this first row. And again, I would definitely make a key to go along with the sample space to indicate what R and what RF means, because that could be confusing for someone who's never seen this before. Either way, whether you make the tree diagram or the sample space, you can see how many outcomes there are. Making a list, you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 16 outcomes if you made a sample space and you just count each outcome from the list that you made. If you look at the tree diagram, you see the 16 outcomes by following the path of the branches. Red, right foot, that's 1. Red, left foot, that's 2. Then 3, 4, and in the end you could just count the last set of branches. So there's 4 here, 4 here, 4 here, 4 here. So that's 16 branches, so there are 16 outcomes. Now a quick way to find out the number of outcomes would be to multiply the number of choices in the first event times the number of choices in the second event. So you would do 4 times 4 to get 16 outcomes. And that is called the counting principle. And what the counting principle says you can do is, for each event, you multiply the number of choices times the number of choices, and you do that for as many events as you have, and that gives you the total number of outcomes. And that's all there is to it. Until next time, my Math Jedi.